2006 second chance. In the complex plane referred to a direct orthonormal system, OUV, consider the points A of fx2, B of fx4, and M of fxz, where z is different from 2. Let M prime be a point of fxz prime such that z prime equals z minus 4 over z minus 2. This is why we set z different from 2, because in the denominator, the z minus 2 is different from 0. 1a. Give a geometric interpretation of modulus of z prime. Modulus of z prime is a distance. It is equal, z prime is the fx of m prime, zm prime equals om prime. Z minus 4 equals modulus of Zm minus Zb. It is equal to the distance Bm. And modulus of Z minus 2 equals Zm minus Za minus Za equals Am. Part B, determine the set of points M when M prime moves on a circle. Determine the set of M when M prime moves in a circle of center O and radius 1. M prime belongs to a circle of center O, radius 1, means OM prime equal 1. It means that modulus of Z prime equal 1. It means that Z minus 4 over Z minus 2 equal 1. So, property of the modulus of Z1 over Z2 equal modulus of Z minus 4 over modulus of Z minus 2 equal 1. It means that Bm over Am equal 1 means that Bm equals Am. So M belongs to perpendicular bisector of segment AB. Part 2. Let z equal x plus iy and z prime equal x prime plus iy prime. Express x prime and y prime in terms of x and y. So z prime equals x plus iy, x plus iy minus 4 over x plus iy minus 2 times conjugate x minus 2 minus iy over x minus 2 minus iy. We expand x minus 2 squared plus y squared. Always, whenever we multiply z by z bar, we get real part square plus imaginary part square. X times x squared, x times minus 2 minus 2x, minus ixy اوكي نشوفها هلا هون. So now we multiply by the conjugate x times x squared, x times minus iy minus ixy minus 2x plus ixy plus y squared minus 2iy minus 4x plus 4iy plus 8 equals ixy minus ixy plus ixy 0, x squared plus y squared minus 6x plus 8 over x minus 2 squared plus y squared. This is the real part. The imaginary part, minus 2iy plus 4iy, 2y over x minus 2 squared. So therefore, this one is x prime. And the second one is y prime. This is what's meant express x prime and y prime in terms of x and y. The last part, when z prime is real, find the line in which the point M moves. Z prime is real means the imaginary part of z prime equals 0. In y prime equals 0. Z prime is real in the imaginary part of y prime of z prime equal to 0, in y prime equal to 0. Z prime is real means the imaginary part of z prime equal to 0. 2y over x minus 2 squared plus y squared equal to 0, cross multiplication. 2y equals 0, and y equal to 0. This is the equation of the x-axis. M belongs to the x-axis. So z prime is real. Imaginary z prime equal to 0 means y prime equal 0. So 2y over x minus 2 squared plus y squared equals 0. So y equals 0. 2007, the first chance. In the complex plane referred to a direct orthonormal system or UV, consider the points E, F, G of respective affixes. ZE equal 2i, ZF equal minus 2i, ZG equal minus 1 plus I. And let M be a point of affix Z. And let M be a point of affix Z. Find the set T of points M when modulus of Z minus 2i equal radical 2. When modulus of Z minus 2i equals radical 2. So Zm, Z is Zm, minus 2i is minus Ze equal radical 2. Em equal radical 2, M belongs to a circle of center E and radius radical 2. So Z minus 2i equal radical 2. Zm minus Ze equal radical 2. Em equal radical 2. Means M belongs to a circle of center E and radius equals radical 2. Show that the point G belongs to T. T is a circle. To prove that G is a point of a circle, we have to prove that the distance from the center to the point is equal to the radius. So G belongs to T if EG equal radical 2. So we have to determine the length of EG. Length of EG equal ZG minus ZE. Equals minus 1 plus I minus ZE minus 2I equal modulus of minus 1 minus I radical A squared plus B squared equal radical 2. So the distance from M to E, the distance from E to M, center to the point M, is equal to the radius. Then M belongs to the circle T. So EG is equal ZG minus ZE modulus of minus 1 plus I equal minus 2I equal minus 1 minus I equal radical 2. So EG equal radius. Then G belongs to T. Part 2a. Find the line L on which the set of points in which M moves when modulus of z minus 2i على z plus 2i equal 1. Z minus 2i is EM over FM equal 1. يعني ME equal MF, يعني M belongs to the perpendicular bisector L of EF. Z minus 2i over, so Z minus 2i على Z plus 2i equal 1 by using the property of the modulus. So modulus of Z minus 2i على modulus of Z plus 2i equal 1. So ZM minus ZE is ME over ZM minus ZE على ZM minus ZF. هذه بتكون E وهذه بتكون F. So ME على MF equal 1. M belongs to the perpendicular bisector of EF. ننتبه ال perpendicular bisector of EF مين هو هون؟ ZE هي 2I ZF minus 2I. The perpendicular bisector of EF is the x-axis. The perpendicular bisector is the x-axis. يعني ال L هو مسمين لنا إياه هون L يعني determine the affix of هون L هو x-axis. Determine the affix Z0 of a point W on L. W is on L. يعني W belongs to the x-axis. يعني W عندها coordinates x0. يعني Z0 equal x. M belongs to L. L is the perpendicular bisector. This is L. So M belongs to L. M is a point on the x-axis. So W, this is not L. W belongs to L. W belongs to the x-axis. W on the coordinates x0. In Z0 is x. To find x, هو قلنا find the affix of a point W, find the affix Z0 of a point W such that Z0, so Z0 is x لأنه W هي x0, Z0 هي x. فنقول radical x squared plus 4 equal 3. Radical x squared plus 4 equal 3. Squaring the two sides, x squared plus 5 equal 9. يعني x squared equal 5. يعني x equal plus or minus radical 5. X equal plus or minus radical 5. Is x equal radical 5? Z0 equal radical 5 or x equal minus radical 5? So Z0 equals minus radical 5. The last part 3. Let A and B be 2 points of affixes ZA and ZB such that ZA is ZF plus ZG or ZB is ZF times ZG. Write the complex form of ZA and ZB. Write the complex form of ZA and ZB in the exponential form. We need to write it in the exponential form. ZA is ZF plus ZG minus 2i minus 1 plus I minus 1 minus I. المودulus radical 2 والargument هي 5 pi over 4. ZB هي ZF times ZG تعطيني 2 plus 2i. المودulus is radical 4 plus 4 هي radical 8 هي 2 radical 2 والargument of ZB is pi over 4 بتصير معنا in the exponential form 2 radical 2 EI pi over 4. The last part, to prove the points that OA and B are collinear. To prove OA be collinear, if we find the angle OA OB, angle OA OB هي argument of ZA على argument of ZB. تطلع معنا الارجيومنت هي argument بدون هودي argument of ZA of ZB على ZA هي argument of ZB minus ZA. Argument of ZB هي pi over 4 minus 5 pi over 4 equal minus pi. Then OA and B are collinear. OAB are collinear. The argument of ZB minus ZA تعطينا pi over 4 minus 5 pi over 4 تعطينا minus pi. Means that OA and B are collinear. Since the angle is minus pi or pi. This is all about this exercise.